Welcome to a brand new video. You can tell that my voice is funny, but not to worry. This video is on what you probably already read the title: first order linear differential equations. And I've just written here that they're of the form dy dx plus or minus p of xy is equal to q of x. So some function of x multiplied by y is equal to a function of x. And mu of x is an integrating factor, where mu of x is equal to e to the integral of p of x dx. So p of x, as you can tell, is that same function that's being multiplied by y. So we have to that's basically saying take the integral of this. That's it. Obviously raised to the power of e to the power of that. So, well, which equation are we going to do today? Well, I'll show you. Dy dx plus 2y over x is equal to 5x squared plus 8x minus 6. That's our equation. So, how do we solve that? Well, what we've got to do is recognize, is it of this form? And yeah, it is, because it's easy. I didn't want to make it too hard. Dy dx, yep, tick, tick. 2y over x, well, that's 2 over x multiplied by y. So that is a function multiplied by y, tick. 5x squared plus 8x minus 6, yeah, that's a function of x, whatever. Alright, we are in business. So, what do? Well, we have to take the integral of 2 over x. So, e to the integral, so mu of x is equal to e to the integral of 2 over x dx, which is just equal to e to the 2 times the integral of 1 over x dx, and that is the natural log of the absolute value of x. That's just equal to 2 e to the 2 times the natural log of the absolute value of x. I'm going to forget about the plus c for now. Plus c can get a life. So this is equal to e to the ln of x squared if you use laws of logarithms. And these are inverse of each other, so we can cancel them out, which means that mu of x is just x squared. Now, why is this important? Well, mu of x is the integrating factor that we multiply the whole expression by. And you'll see why in a moment. It's the coolest thing ever, I'm telling you. So, x squared dy dx plus 2 over x y is equal to 5x squared plus 8x minus 6. That's not a star, that's an x. What next? We just expand it out. So x squared dy dx plus 2xy is equal to 5x to the 4th plus 8x to the 3rd minus 6x squared. Alright, cool. I'm sure we're all in agreement that that's the truth. Now, I'm going to show you the coolest thing on the planet. Seriously, pay attention. You're going to love this. This is exactly why linear differential equations are different to separable ones. So, every single time you do one of these problems, I encourage you to do this, because this is exactly what I do. And it makes it so clear. So, pay attention, alright? So, I'm going to write something out, and I want to see... I'm going to tell you what it is, but I want to know if you know what it is, like in your head. Alright, in case you don't even know, alright, so this is the derivative of a product. This right here is exactly this. So the whole point of linear differential equations is we're trying to factorize this back into this form. I know, it's crazy, but you gotta trust me, man. I'm sure you already know this, but if you need clarification, that's what I'm doing. So, what do we know? I know that f dash of x corresponds to dy dx, because dy dx is f dash of x. That's just different notation. It means the same thing. And if that's true, then that means that g of x is x squared, because that's the function of x that's being multiplied by that. Now the whole point of this process is we want f of x and we want g of x, and we're going to put them into this form, d over dx. So I know that g of x is x squared. Now I need to find out what f of x is and what g dash of x is. Well, if I took the integral of this, that's going to give me y, because the integral of d over dx cancels each other out and I'd be left with y. So that means that this y corresponds to f of x. I'll just draw an arrow. It's very messy, I know, but that's it. So the derivative of x squared y. So basically what this is telling me is if I took the derivative of this, I would get this back. And I'll prove it in the next video. So enough of rubbish. I'm just going to skip to the next part. 5x to the 4th plus 8x cubed minus 6x squared. Now we integrate both sides, just like separable differential equations. Cancel, cancel. That's the beauty of linear differential equations, because now I'm just left with x squared y is equal to the integral of all of this. Now, this is the easiest integral on the planet, almost, except for e to the x. So how do we do this? Well, this is 5x to the 5 over 5, so that's just x to the 5 plus 8x, oh, that's 8x cubed, sorry, I forgot that. So this is 8x to the 4th over 4, which is just 2x to the 4th, minus 6x to the 3rd over 3, well, that's just minus 2x cubed, plus c. And now we can finally solve the differential equation. So y is therefore equal to x to the 5th plus 2x to the 4th minus 2x cubed plus c all over x squared by taking the x squared to the other side. And that's how you solve first order linear differential equations. Peace out.